Hello everyone and welcome to Class 5. Today we're going to talk about one-way ANOVA and repeated measures ANOVA. As usual, we start our class with an overview of the lesson objectives and the lesson topics. So if you're interested in reading over those before we get started, please go ahead and stop the video and read through those now. So the first thing we need to do is look at the power analysis. And today, rather than focusing on how to do the power analysis, I just want us to focus on interpreting the information that's here in the slide. One of the things to know about this slide and the next slide is that you have to have some pre-existing data to be able to run this power analysis. That's what the a priori is telling you. You can see that right up there at the very beginning where it says type of power analysis. You have to have pre-existing information about the survey that you're using to be able to do this power analysis. That said, I don't want to step through that or try to recreate it. What I want to do is just talk about the information that is provided here on this slide. So let's start with the effect size. Notice that the effect size is an F effect and that it is 0.16. That effect size was determined by the information that was put into another slide. See where it says determine? When you hit determine, it pops up another slide, and in that other slide you're going to enter the information for the means of the groups and the standard deviation, the pooled standard deviation for the group. You can know how many groups were entered in. Information for groups was entered for this particular study by looking down there at the bottom of that column. You see it says that the number of groups equals 9. So 9 groups of information about means and the pooled standard deviation for those 9 groups was entered into another slide, and given that information, then G-Power calculated what the effect size was for that study. It came up with 0.16, and you'll see in a slide later on how you interpret that as whether it's small, medium, or large. Of course, we're going to, as standard procedure, set our alpha level at 0.05 and our power at 0.8. So with that information entered into the pane on the left, it then calculates what's the total sample size that you need. And it came up with a total sample size of 603 to be able to achieve a power of 0.80. Now, my guess is that for this particular one, there are an equal number of people in each group. And I'm just guessing because that tends to be the default for the ANOVA when you run that, is that it's going to be an equal number. You can have an unequal number of people in the groups. It's probably going to result in you needing a few more people in your sample size to achieve the power that you need. But that's just a guess. You have to put your information in. You know, all of that's going to be driven by effect size too. So put your information in and see what happens. In this particular slide, we're looking at repeated measures ANOVA. So one way ANOVA, you're going to be doing 3 or more independent groups. Repeated measures ANOVA is when you've got matched, like paired samples, pre and post test. I'll get it out eventually. You have a pre and post test, and then you've got multiple independent variables. So that said, let's look at the information here. Again, this repeated measures was computed a priori, telling you that it was, the power was computed before the study was conducted, so that you would know how many people that you needed to have in your sample. Notice again that your effect size is 0.16 Your alpha level is 0.05, power that you want to achieve is 0.8. At this point, it's telling you that you have one group and 3 measures. So it's your independent variable, right? It's your repeated measure that it's talking about. So it's your grouping variable is what you're looking at. So you have 3 grouping variables. So as an example, you may have as your dependent variable, we've used this before, the perception of attitude or attitude toward the environment. Let's use that as our dependent variable. What is the attitude toward environment? So for it to be repeated measures, maybe you measure a group of 4th graders' attitude toward the environment on the first day of school, at midterm, and on the last day of school. You have 3 measurements of the same group of people. That's what this power analysis is going to look to see, how many people you need to achieve a power of 0.8, given that your effect size is 0.16. And if you look over there on the right-hand side of the pane, you see that the sample size needed is 77. And with that number of people, the actual power is, again, 0.8. Again, you're going to have some information from prior studies about means and the pooled standard deviations from those studies. Okay, let's talk about the assumptions of the 2 different types of ANOVAs. One-way ANOVA, let's look at 2 examples just to make sure we're clear on which one is which. One-way ANOVA would be, again, we'll use our attitude toward the environment example. With a one-way ANOVA, you've got attitude toward the environment, and maybe you look at the difference between 3 different groups of people, like freshmen in high school, sophomores in high school, and juniors in high school. 3 independent groups, different groups of people. Repeated measures ANOVA is like our prior example, attitude toward the environment. You had a single group of people, let's say we did the freshmen in the high school, and you looked at their attitude toward the environment on the first day of school, midterm, and last day of school. Repeated measures. All right, now let's look at their assumptions now that we've kind of got clear on what our examples are. On one-way ANOVA, you're looking for homogeneity of variance. Remember, we discussed that last week when we were doing t-tests, looking to see that the variances among the different groups is approximately equal. In repeated measures ANOVA, you have something very similar, and it's called sphericity. So sphericity is the equivalent of homogeneity of variance, but it's in the repeated measures ANOVA analysis. In a one-way ANOVA, you've got an independent variable that has at least 2 or more categorical, freshmen, sophomore, juniors, seniors, independent groups. You can't obviously be a freshman in high school and a senior in high school. Or if you can be both at the same time, you can only have their response to the survey one time in one group. Independent observations, that's the one time in one group part, right? A continuous dependent variable, the construct with a mean for the attitude toward the environment, normality of distributions within groups, and no significant outliers. And I will go ahead and tell you that I usually define significant outliers as any of those who have scores that are 3 standard deviations from the mean. And I'll take those scores and I'll convert those to z-scores. And if the z is 3 or more standard deviations from the mean, that person's score gets not deleted, because you lose a lot of data if you delete, right? But excluded from the analysis. Okay, for repeated measures, we've already talked about sphericity. You have an independent variable that has at least 2 categorical related groups or matched pairs. You have a continuous dependent variable. You have distribution of the dependent variable in the two or more related groups should be approximately normally distributed. So the related groups would be like the beginning of school, midterm, end of school time periods, and then again, no significant outliers. You do need to look at testing your assumptions. Many of these you can just eyeball. That's what the eyeballs are for. You can look at it and see if the assumption is met. For instance, is your dependent variable continuous? Do you have at least two or more categorical independent groups? Do you have independent observations? Do you have matched pairs? Those are all things you can just look at and see. Is that occurring in your data? No significant outliers. You do have to test for that. Normality of distributions within groups, and distribution of the dependent variable in the two or more groups should be approximately normal. So all of those are things that you'll need to run tests for. And we'll add a supplementary video soon that talks about testing those assumptions. All right, so 2 types of ANOVA. We've already gone over what those 2 types are. Let's look at some other examples in action. All right, one-way ANOVA. Our dependent variable is job satisfaction, and we want to know if there is a difference in job satisfaction among 3 groups of people: single women, married women, and divorced women. So we're using the same dependent variable across all 3 groups, and we have 3 different groups. One-way ANOVA. Now, there's 2 different ways to look at repeated measures ANOVA. I've already talked to you about the one about time. Let's look at the example, or a different example about time one more time. Or again, let's look at it again and see a different example. All right, so again, same dependent variable, job satisfaction. Now we're going to look at the same group of people. In this case, it's married women across 3 different time points: time 1, time 2, time 3. And you can define that at any point in time. It could be at early career, say year 1, mid-career, year 5, late career, year 15. However you want to define that time period. And that's a long time between times 2 and 3, so maybe you do it at 10 years instead of 15. But anyway, that's kind of what you do in terms of time. Set a time period. Another way of looking at a repeated measures ANOVA is across condition. Again, the dependent variable remains the same, job satisfaction. We've got the same group of people. In this particular case, we're going to do women. We have 3 different conditions. The job satisfaction of women who work alone, who work in teams, and who work in both teams and alone. So 3 different conditions. So if I were a part of this study, I could only be a member of one of those groups. I couldn't be in multiple groups. Okay? So as an example, I could not be, my scores for job satisfaction could not be included in both the women working alone group and the women working in both teams and alone. Can't do that. Got to be in a single condition. So just so we're clear on that. Okay, study objectives are really, I think, easy this time because they match with the previous examples we just looked at. The one-way ANOVA to determine if a difference exists among single, married, and divorced women on level of job satisfaction. If you need to, stop the video, go back and look at the picture, come back and read the objective, get it clear in your mind how those 2 connect. The second objective is the repeated measures ANOVA for time to determine if level of job satisfaction among married women changes during the first 3 years of employment with XYZ company. So does job satisfaction change during the first 3 years? Now look, there's no indication of what direction the change could go. It could be a positive change in job satisfaction. It could be a negative change. No hypothesis, I guess, is made about the direction of the change. It's simply a question of, is there a change? And then the third one is about condition, to determine if work environment influences women's job satisfaction. So if you think about those three conditions, working alone, working in groups, or working in both in groups and alone, those are work environment influences, right? So that's the point of that objective. Again, if you need to, stop the video, compare the objective to the picture, and see if you can get that set in your mind, how those three all align. Okay, this is the short, sweet, and to the point information on how to do a one-way ANOVA. And these are the instructions for doing this in SPSS. And you start at the top by clicking Analyze, then going to Compare Means, then going to One-Way ANOVA. One of the things you do need to do is choose a post hoc test, and Tukey is one of the more conservative ones that you can use, and that just tends to be my default. There are others. You can look at those and make a decision. That just happens to be the one that I tend to use. You also need to go to Options and click the options to get both descriptives and homogeneity of variance, because if you do not do that, you're not going to get the means for the constructs, and you are not going to get that test of homogeneity of variance. So make sure you click those things. Okay, now let's look at the output. One of the first things you want to do is look at the means. Remember back in the power analysis when we were looking at 9 groups? Okay, so what we have here are means for 9 different groups of people who participated in a camp, and we assessed their perception of youth-adult partnership, YAP. Okay. So you can see too that each of the groups had a different number of people in the group, and you can see what the means and standard deviations were for each group. So if you need to, stop and look at that information, and then we're going to roll on to the next part of it. All right, so we went ahead and we ran our one-way ANOVA. The first thing you always do is check, after you look at the means, that is check the homogeneity of variance. Notice that it says the p-value is equal to 0.111. That's a good thing. You want the p-value on your Levine's test of homogeneity of variance to always be greater than 0.05. That indicates that variances among the groups are roughly equal. Homogeneity of variance is good. Let's roll on to the next part. So now we just need to know, was there any significant differences among the 9 groups? And guess what we see? There was significance. Your p-value in this case would be reported as p less than 0.001. All right. Some other information that you're going to need later on, might as well go ahead and when you do your ANOVA, you might as well just copy this table, because you're going to need all of this information pretty much. You're going to have to report the ELF value, 6.58, the significance, p is less than 0.001. You're going to need the sum of squares information for both between groups and total. You'll need that for your effect size here in a few more slides, so jot that information down. You're also going to report the within groups sum of squares. You're just not going to use it in any further calculations. Okay, main effect is significant. That's good. Let's see where the differences were. Well, as it turns out, the mean for the group for week 7 was significantly different from 1, 2, 3. I see 3 different weeks where there was significance. Can you stop the video and find that for week 7? Okay, what I see is that week 7 was different from week 1. P equals 0.009. Week 7 was statistically significantly different from week 3. P is equal to 0.001. And week 7 is statistically significantly different from week 8. P equals 0.011. So that answers the questions of which weeks had statistically significant different scores from week 7, and what was the p-value. Now let's look at the next little part of that table, because we also see significance for week 9. So the week 9 score was different, statistically significantly different from weeks 1. P is less than 0.001. Week 3, P is less than 0.001. Week 5, P equals 0.002. Week 6, P equals 0.007. And week 8, P is less than 0.001. And you may be saying, well, what direction is this? I mean, is week 9 less than or more than each of those weeks? Let's just remember that 9 is significantly different from weeks 1 and 3, okay? And let's roll right back up here to these means. What was the mean for week 9? 2.33. What was the mean for week 1? 3.05. And the mean for week 3, 3.20. So essentially what you're seeing is week 9 was so low on the mean that those others that had high means were significantly different. So you can take the mean table and overlay that with your significance table, and then it'll make a whole lot more sense. All right, let's skip ahead again. The other thing to be sure that you check on is confidence intervals, because you know we're going to have to report the confidence intervals, right, when we write our report. So if you go back to the previous slide, you can see that the confidence intervals for all of the weeks that had statistically significant differences show numbers that are all on the same side of 0, right? So for week 7 versus week 1, you can see that the lower bound and upper bound are both negative numbers, right? And remember that when they're both on the same side, that just gives you more confidence about that significance. And then just kind of glance down through there and you'll see that the others share the same thing. Okay, now we have to work on that effect size. Remember I told you earlier that you needed to jot down the sum of squares between and the sum of squares total. Okay, let's scroll back a couple of slides, right? Sum of squares between 27.53, sum of squares total 195.44. You can carry it out to the third decimal if you want to. In fact, I do so myself sometimes when I'm computing this. It's up to you. Either one's fine. All right, got that information written down? Good. Let's go plug it into the formula. So the 27.531 divided by the 195.442 gives you an eta squared of 0.141. But you know what we really are after is an f value, so we've got to convert eta squared to f. And to do that, we're going to take eta squared divided by 1 minus eta squared and take the square root of that. And if you do that computation, you're going to come out with F equals 0.405. How do you interpret F? Well, if you look at your table, you see that that is a large effect size. So that tells you right there that the differences among all these groups is a large effect. Now we need to report our results. And what I'd like to challenge you to do is to take this slide and then go back and fill in all the information that you have from the previous slides on the one-way ANOVA results, and see if you can get this report written, so to speak, using this template. Okay, so 3 things that you've got to do in your report. 1, you've got to write a sentence or sentences that tells what the significant effect was. So there was a significant effect of week, i.e. the week that the group attended the camp, on their perception of youth-adult partnership. You're going to give the F value. You're going to give the degrees of freedom between and degrees of freedom within. You're going to give the p-value. I think it was p less than 0.001. And the effect size that we just computed, F equals 0.41. Planned contrasts. I'll show you what that is referring to. Let's just back up. It makes it easier. These are your planned contrasts, your contrasts between the weeks, okay? So planned contrasts showed you that there was an increase or a decrease or a difference between, say, week 7 and week 1. And you'll have to look at the means to figure out what number goes where. So the difference is between weeks 7 and 1. We don't have the t-value on any of these slides, but when you run this in ANOVA, you'll find your t-value. So report your t-value with the degrees of freedom, the p-value, your significance level, and the F or effect size for your planned contrast. And then you've got your slide here, and you just need to replicate what was. Let's back up. Remember I told you to write all that down? Go forward and plug it into that table. So always report those 3 things when you do a report on a one-way ANOVA. The next thing you would look at is a repeated measures ANOVA. And so the text here steps you through all the choices you need to make. One of the more confusing things is this little screen here where you have to define the factors. So what I want you to notice is that the within is the independent variable. So see where it says within subject factor name. Time was one of our within subject factors. Remember, we gathered 3 different time points. That's why you have the 3 levels. And then the measure name, see where it says measure name, is going to be the name of your dependent variable. Now you have to drag those actual time variables and the dependent variable over into the appropriate boxes. But you're going to see how to do that in your actual data set. And then you have to, once you've gotten that information in there, click the button that says define. Right now it's grayed out. That's because I didn't pull anything over, right, before I took the screenshot. But once you pull it over, you can hit define, and then you've got to do the screens for contrasts. You have to change your contrast to repeated. You have to do options and do display means for dependent variable. And then you need to check compare main effects. For the CI adjustment, you want to do Bonferroni. For the display, you want to choose descriptives, effect size, and observed power. So do all those things, hit OK, and it's going to run your test. And then you get some output. Again, we start with look at the means for each of the time points. So you've got year 1, year 2, and year 3. And you notice that in year 1, that's your baseline, went up in year 2 and went down slightly in year 3. So we're going to look at, was there a significant difference among those years? Okay, so let's look at our results. Well, first we need to look at Mockley's test of sphericity. Remember, that's the homogeneity of variance equivalent. It's not significant, so P equals 0.271. That's good. Sphericity, or variance among the time points, is assumed. Equal variance among the time points is assumed. Now we've got the 3 time points, what we call the omnibus test. Was there a difference among the 3 time points? Well, the bad news here is there wasn't enough difference among those means. So the p-value equals 0.07. In truth, you're done. The only statement you can make about this test is there was no significant difference among the time points. You're done, you can't say anything else. But we're going to continue on just to look at it to demonstrate what you would have looked at had the p-value been significant. The next thing you look at is the pairwise comparisons. So the dependent variable, remember, is peer belonging, and it is comparing times 1 to 2 and 1 to 3 and 2 to 3. And you can see that right here in those first 2 rows. Again, the omnibus wasn't significant. You wouldn't expect to see significance here. I'll tell you what does happen sometimes though. If it's what I call barely significant, let's say the p-value had been 0.05. Sometimes when you run this test, you get over here and you don't find significance between time points. That happens. There's nothing you can do about it. Usually if you have a highly significant omnibus overall test, then you're going to find significance among time points. But sometimes that just barely significant isn't really significant enough to make a difference. And unfortunately, at that point, you have to report that even though the omnibus test showed significance among the groups, once the pairwise comparisons were run, there was no significant differences between time points, or between conditions if you have a condition one. Had you had significance, remember that you do need to report your confidence interval right there. And again, some kind of statement about the significance of the effect of time on pure sense of belonging. F value, degrees of freedom for the dependent variable, degrees of freedom for the error, the p-value, and the effect size. Now obviously, if there is no significant difference, there's no effect size, right? And that's come up a little bit. People think, well, if there's a question posed about effect size, I must have done something wrong. Well, no, not necessarily. It's just, again, a question of, do you understand that if there's no significance, you don't report effect size, you don't report anything. You just make a statement. There was no significant effect of time on whatever the dependent variable was. There is an interesting article out there. You know, when we were doing the effect size, we converted the eta squared to F. There is an interesting article out there that you can read that talks about using the generalized eta squared as an appropriate measure of effect size. I've included the link for you, so use that if you have an interest in that. Okay, test review. So some things to make sure you understand before the test, which by the way is in 2 weeks. Reading and interpreting output. Can you read and interpret what the output is telling you? Can you write a research objective? More importantly, can you critique an existing research objective? Can you report the results? You know, the table, the sentences about the effects, etc. Can you remember what the assumptions are? And I say it like that because I tend to ask more knowledge-based questions about assumptions. I'm not going to ask you to test any assumptions on the test. I'm just going to ask you, are these the assumptions for a one-way ANOVA? Or I may ask you, out of this list of assumptions, which one is incorrect for a one-way ANOVA? So for instance, if I put the assumptions for one-way ANOVA up there, and I said, which one of the following is not an assumption of one-way ANOVA? And one of the options was sphericity. Well, that one would be the one that's incorrect, right? Because homogeneity of variance is the assumption for one-way ANOVA. Sphericity is actually the assumption for repeated measures ANOVA. If I gave you the formula for the one-way ANOVA effect size, in fact, I don't have to give it to you, you have it already in your notes. And if I gave you the output for a one-way ANOVA, which I would give to you on the test, could you calculate the effect size? Because that would be a question I would ask on the test. If I gave you some objectives, can you select the correct objective? Or can you select the correct test? If I give you, if I give you a repeated measures ANOVA objective, and I say, given this objective, which test is correct? And I gave you the options of t-test, one-way ANOVA, repeated measures ANOVA time, or repeated measures ANOVA condition. Could you choose the correct option or correct answer? And that's it. We're at the end of lesson 5 and one-way and repeated measures ANOVAs. So again, if you have questions, reach out to me. Send an email. I have not had many questions, but those that have come across on email, I'll either email you back or I will give you a call. All right, good day.